This is a hole on top of the Shanghai World Financial Center. This is a 660-ton steel ball hanging inside of Taipei 101.
Slow it down. This is a little bit too fast for me. I think I might need a coffee for this. Alright, let's reset and start again.
This is a hole on top of the Shanghai World Financial
Hole in the
Center.
building.
This is a 660-ton steel ball hanging inside of Taipei.
A steel ball?
And these are massive clockwise balconies on the Burj Khalifa, the tallest building ever
Balconies?
made. These design choices might seem like gimmicks to give these skyscrapers their iconic
Yes.
looks, but behind each feature is a brilliant engineering trick designed to do one
Got it.
thing. Confuse the wind.
Confuse the wind.
Wind can cause a bunch of issues for buildings: broken windows, structural damage, and discomfort for the people inside. And today's super skinny skyscrapers have to deal with a particular wind-induced phenomenon called vortex shedding.
This happens when wind flowing past a building.
So there are generally two forces of nature which a high-rise building would need to design to resist, the first being wind and the second being earthquake. There are generally two criteria which a high-rise building would need to satisfy, first being strength to make sure that the building doesn't collapse, and stiffness to make sure that the building doesn't sway too much.
Creates vortices, strong swirls of air that magnify the damaging effects of wind. In low winds, these vortices cancel each other out, but in higher winds they create alternating low pressure zones that make the building rock back and forth. As the wind speed increases, so does the intensity of the back and forth movement.
Well, you may ask, how do we measure this and how do we measure wind? Well, during the design phase, the design team would typically build a small model of the high-rise building and put it into a wind tunnel test in which winds of various speeds will be directed towards the building in all directions, and how the building behaves will be recorded and measured.
Every object also has its own natural sway frequency, and when that matches the frequency of vortex shedding, it creates a dramatic spike in the intensity of swaying. On the top floors of a high-rise, that kind of swaying can be nauseating, plus it can damage the integrity of the building. But architects have an arsenal of tricks to reduce movement.
So, architect generally leads the creative process of the look and feel of the high-rise building. The architect would typically lean on the building structural engineers to advise on building movements.
The first one, tapering. The higher up you build, the stronger the wind force gets. So to reduce surface area where wind is stronger, designers can simply make a building skinnier as it gets taller. They can do that with tapering, like the Shard in London, or with periodic setbacks, like the Willis Tower in Chicago. Then designers can soften edges. Hard edges aren't good on wind, so you'll often see skyscrapers with round corners, but architects can achieve a similar effect with small cutouts from the edges. Take Taipei 101, for example. The building was originally designed with square corners.
I will now put on a builder's hat and start thinking about construction methods. Builders generally prefer a simple and consistent looking building design to speed up construction. Time spent on site is actually money spent, and in the construction game, you really want to speed up your construction to save cost.
But when a scale model was tested in a wind tunnel, the designers saw a lot of swaying. Here are the results after designers added sawtooth corners. They reduced movement by 25%. The next option is pretty simple. You can just open it up with holes. Skyscrapers like Saudi Arabia's Kingdom Center and Shanghai's World Financial Center do this with a single gap up top, allowing wind to pass through where it's blowing the strongest. But 432 Park Avenue in New York achieves this effect with several double floor cutouts that allow wind to pass through along the length of the entire tower.
I will now put on a developer's hat. Generally speaking, loss of floor space is loss of possible income. So as a developer, you really want to make sure that the design team is really maximizing the potential of the building and really pushing the limits in terms of creating space based on the site that you've got.
There's also twisting. This wind resistance technique makes for some of the most stunning skylines today. Dramatic spirals redirect the wind, guiding it upward and off the building. That's the same wind resistance trick used by some industrial chimneys and car antennas.
That's really smart.
Corkscrew shapes like this were impossible to build until fairly recently, thanks to advancements in software and material science. And they're also promising from a sustainability perspective. During the design process on the Shanghai Tower, for example, adding the iconic twist reduced the wind load by 24%, saving developers $58 million in structural material.
So during the design process, usually a cost estimator would be involved to provide advice on the cost of construction before construction even starts. As a developer, you really want to be tracking your cost and make sure that you're not over budget.
Finally, there's a technique so good, it's invisible. Damping. Dampers are mechanisms designed to absorb the energy from a building's movement, counteracting the effect of the wind. Skyscrapers do this in two major ways. First are slosh tanks. These are containers filled with several tons of water. The water sloshes back and forth, and its weight displacement helps keep the building from swaying. Second are tuned mass dampers, massive weights suspended in the middle of a building. These were traditionally hidden away in building design, placed on empty floors with other technical equipment. But they don't have to be. Taipei 101's tuned mass damper has been a popular tourist attraction since it opened in 2004. They even have a mascot for it, Damper Baby.
That is so cute, Damper Baby.
Weird.
These shapes, holes, and counterweights form a secret design language hidden inside of our skylines. And as more people move out of rural areas and into urban ones, skyscrapers will keep getting taller and skinnier.
So the other reason that buildings has to go taller in the future is the limited amount of land that is available in good locations that is in such a great demand. So, agree.
These technologies are what's making that future possible and letting us keep building into the sky.
Look, great video, very informative. If you want to see more of this type of reaction videos, hit the like button and leave a comment below on what other videos you'd like to see. Until then, signing off for now.